Hello students. We're going to do something a little unusual in solving this differential equation. In fact, we're really not going to solve it at all in the conventional sense. We're going to actually guess the solution and check that is in fact a solution to this initial value problem. Initial value because if we think of t as time, then time is 0, and that would be the initial time. Not that the initial time has to be 0, but we're just going to start at 0, and that the value of the function at that initial time of 0 is equal to 5. So the reason that we're going to do it this way with the guess and check is that when you learn the procedures for solving these types of problems, I don't want you to shut your mind off and just go with the procedure and think of the procedure as the silver bullet. I would like you to look at these problems and don't be afraid to take a guess and use your intuition. Then when you do the procedures, sometimes that intuition can help guide you through the procedure when the problems get to be a little more complex, and they may require you to use your intuition to finish the solution when it's not so straightforward. Okay, so without further ado, let's do a guess and check on a very simple problem like this one. So the first thing we notice is that y of t is a function that equals its derivative times a constant. So if you look up here, you have you take the derivative of y and you get y back again, and you multiply by constant. Okay, well, we know a function that has that behavior. 0 would work because the derivative of 0 is 0, and 4 times 0 is 0. However, we run into a problem if we use that because our initial value is 5. And so y of t can't be 0 for all t because y of 0 is equal to 5, that initial value. So it can't be 0. So we have to go with another function that fits that behavior, would be e to the 4t. And so what I did is I cleaned this up a little bit, and I just rewrote the initial value problem, the IVP, right here. And so let's guess initially y of t equals e to the 4t. Now certainly it fits the bill because if you take the derivative of y, the 4 comes down because of the chain rule, and you have 4 times e to the 4t, but e to the 4t was y of t, so yeah, so check, that satisfies the differential equation. However, we still have the initial value, which is not satisfied in this case. So because if we plug in y of 0, for this solution, we get 1, and y of 0 is 1, does not satisfy the initial value. So we need to multiply this by 5. So if we try y of t equals 5 e to the 4t, then since y of 0 is 5 e to the 4 times 0, which e to the 0 is of course 1, and that equals 5, that satisfies the initial value problem. So once again, if we check that, if we take the derivative of this function, the 4 drops down here, 5 e to the 4t, but 5 e to the 4t is y, which we put here, and sure enough, we've satisfied the differential equation, and y of 0 equals 5, which satisfies the initial value. So this solution, 5 times e to the 4t, satisfies this initial value problem. So let's sum that up. Given this initial value problem, we guessed a solution, y of t equals 5 e to the 4t, and then we went ahead and checked that it satisfies the initial value problem, because if we plug in 0, we put a 0 in here, e to the 0 is 1, y of 0 is 5, and then once again, remember that when we took the derivative of this function, the 4 drops down because of the chain rule. The derivative of e to the 4t is e to the 4t, then the 4 drops down, which gives the 4 times y, and that was 4 times the original function. So guessing the solution gets us to this point. And so our intuition tells us, well, if we ever see this kind of situation where we have a derivative and it gives itself back again, we expect the solution to have some kind of exponential behavior, and we might need to figure in a constant. And also, the other thing that might surprise some students is that the constant, the initial value constant, multiplies the function. It's not a plus c like you are used to when you did integration problems. All right, so hopefully this gets you thinking about problems ahead of solving them using the procedures. Take a look at them. Don't be afraid to take a guess and get a rough idea of what you think the solution might be. Then go ahead and start to do the hard work of procedurally solving the problem, if at all possible. All right, good luck.